and we're going to have to throw it in to both tails. Now we set our significance level earlier on to be 0.05, so we're going to put in over here 0.025, and 0.025 of the area goes into this tail. Okay. So the question now is, what are these critical values? What are these critical regions that have 0.025 of the area to the left and also to the right? In other words, what are these critical regions that have 0.025 of the area in either tail? Okay. Now to figure that out, we're going to need to go to our we're going to need to go to our z tables. Okay. So our z tables, what we're going to do is in our z tables is we're going to look up. Okay. Well, our z tables give us cumulative areas. Okay, the z tables gives us the areas up to a particular, the cumulative area up to a particular value. So actually, with respect to this critical value here on the right hand side, the area over here is 0.025, which means that the area from negative infinity up to it, okay, must be 0.975. In other words, 0.9750. So actually, I need to find 0.9750 in my tables. I need to find out what column it's under and what row it's under, because that gives me the appropriate z-score. So what I'm going to do is I'm just going to take my tables. I'm going to take my tables and my z tables. And here's my z tables. We've already given these out to our students, but it's just a standard set of tables, but they're cumulative probabilities. And I'm looking for 0.9750. So 0.9750 in this particular instance here actually is there. There's the value right here. Can you see that? It's a bit fuzzy. It's 0.9750. There it is here. Okay. It's under the column heading 0.06 and it's on the row 1.90. So actually this value here is under the column 0.06 and it's on the row 1.90. So the z-score that has 0.9750 the area to the left of it is 1.96. That's the z-score that I'm interested in. Okay, so 1.96. In other words, this particular value here, this demarcation point right here, is at 1.96. And through symmetry, this demarcation point over here is at minus 1.96. Let me draw that again. Okay, so a little bit clearer. Okay. So our rejection region over here and over here is at 1.96 and it's at minus 1.96. They're my rejection regions. Okay, and what I have is I have my areas under the curve. We know that the areas is 0.025 and 0.025 here. But look, let's look at this. Our test statistic is 2.22. So where does our test statistic? Actually, it's positive. Our test statistic is in here. There's our z value that's equal to 2.22. Our test statistic. So it falls in the rejection region. Okay. So now, what we're saying is, based off this evidence, we can reject. We're going to throw this away and we're going to reject, which is what we're saying is that the actual samples that have been drawn from them two populations, okay, that there's evidence to suggest that the true proportions are actually different to each other. Okay, that there is a different strategy being applied to those two different banks. There is a different proportion of people allowed to trade down in one bank compared to the other bank. Okay, so our decision. So we're going to do our decision in relation to this here. So let's write up our decision, step 5 in our particular test. So we're going to have a look at our decision. So step 5, which is our decision. And in this case here, okay, I'm actually going to throw, because it's a two-tailed test, I'm just going to throw away the signs, because if this was over here, I'd still reject. But I'm going to throw away the signs. I'm looking at the absolute value. So clearly, the absolute value of my z-statistic, okay, my evidence, how far my evidence is away from the null position, okay, is bigger than the absolute value of my critical value. And what I mean by that is the z-statistic, which is 2.22, is bigger than 1.96. Okay, and as such, we reject H0 in favor of HA, okay, at the 5% level of significance, and now we can make our inference, significance, okay, and we infer, yeah, okay, that the that the true population proportions, population, okay, proportions, proportions, with respect to keeping tracker mortgages, mortgages, that the true population proportions are different, that they are different. See, when we reject, and don't forget, even our null position is a statement about the populations that the samples have been drawn from. And our alternative is a statement about the populations that the samples have been drawn from. So when we reject, what we're saying is that the proportions, that these two samples seem to be taken from two different populations. In other words, they've been taken from two different processes. Two processes that are behaving differently. And actually, what are them processes? Them processes are all about the number of people that are allowed to keep their tracker mortgages when they downgrade their home to a smaller home. Okay? And what we're saying is we're rejecting, so actually the proportions are different with respect to both of these banks that we've observed. Okay? So guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this particular test, a hypothesis test, which looked at the difference between two population proportions, was another test in our series of tests dealing with hypothesis testing. I hope that this video was in some way intuitive, and more importantly, I actually hope that was helpful for you, and thank you for watching. Okay, bye bye.